Modern cities are becoming dense networks of connected sensors. Cameras, traffic systems, wireless towers, smart city surveillance, and how 6G connectivity is mapping your every physical movement. 6G technology is still under development, but researchers across multiple countries are already testing systems designed to deliver extremely high-speed wireless communication using sub-terahertz and terahertz frequencies. These frequencies can carry enormous amounts of data with very low latency, allowing faster communication between devices, vehicles, robots, industrial systems, and artificial intelligence platforms. The goal is not simply faster internet. The goal is continuous machine-to-machine coordination across entire cities. What makes 6G different is that the network itself may become a sensing system. Current wireless signals already interact with physical environments constantly. Walls, furniture, vehicles, weather, and human bodies all affect how signals move through space. Advanced AI systems can analyze these disruptions and use them to estimate movement, positioning, and environmental changes. Researchers call this integrated sensing and communication. In simple terms, the same signals used for communication may also function as environmental scanners. Instead of requiring cameras alone, future wireless systems may detect movement through signal reflection, interference, and disruption patterns. Some experimental systems can already identify body movement, breathing patterns, posture, and object positioning using wireless signal analysis. This technology relies heavily on artificial intelligence. Wireless environments are extremely complex, especially inside cities. AI systems process massive amounts of signal data to identify patterns humans could not interpret manually. Over time, machine learning models become better at distinguishing between different types of movement, materials, environmental conditions, and behavioral patterns. Supporters argue these systems could improve urban efficiency dramatically. Smart traffic systems may reduce congestion. Emergency services could locate people more quickly during disasters. Buildings may optimize energy use automatically. Autonomous vehicles may communicate instantly with surrounding infrastructure. Hospitals could remotely monitor vulnerable patients without wearable equipment. Industrial systems may operate with near real-time coordination. However, the same infrastructure also creates surveillance capabilities far beyond earlier systems. Traditional surveillance depends heavily on visible sensors, such as cameras, microphones, or tracking devices. Wireless sensing systems may eventually operate continuously in the background without obvious physical observation points. The network itself becomes part of the monitoring system. One reason this concerns privacy experts is because wireless sensing may work in conditions where cameras are limited. Optical systems can be blocked by darkness, smoke, or physical barriers. Radio frequency systems behave differently. Some frequencies can detect movement and positioning indirectly through walls or around obstacles by analyzing reflected signal patterns. Researchers have already demonstrated experimental systems capable of detecting human motion, estimating occupancy inside buildings, monitoring breathing patterns, and identifying gestures using wireless signals alone. Most current demonstrations remain limited and controlled, but the technology is advancing rapidly alongside AI processing capability. Smart cities are particularly important because they centralize massive amounts of connected infrastructure. Traffic sensors, environmental monitoring systems, public transportation networks, emergency systems, wireless towers, connected streetlights, and mobile devices already create continuous streams of urban data. 6G networks may unify many of these systems into integrated sensing environments. Artificial intelligence plays a critical role because the volume of information generated by smart cities is too large for humans to process directly. AI systems identify patterns, anomalies, movement flows, behavioral trends, and predictive models automatically. In some cases, urban systems may begin responding to behavior in real time through automated infrastructure adjustments. Governments and technology companies often describe these developments in terms of convenience, efficiency, and public safety. Smart infrastructure may improve energy management, transportation flow, environmental monitoring, and emergency response coordination. Many cities already rely heavily on algorithmic systems to manage traffic, utilities, and surveillance networks. The concern is that predictive monitoring may gradually expand beyond infrastructure management into behavioral observation. Once systems can continuously model movement patterns across populations, they may also identify routines, associations, crowd behavior, or unusual activity automatically. Human movement itself becomes analyzable data. This creates major questions about consent and transparency. Most people understand when they are being filmed by visible cameras. Wireless sensing environments are far less obvious. Citizens may not fully understand how much environmental information modern infrastructure can collect or infer indirectly through signal analysis. Privacy law has struggled to keep pace with these changes. Traditional surveillance regulation was built around physical observation tools such as cameras, microphones, or direct data collection. AI-driven environmental sensing systems operate differently because they often infer information through statistical analysis rather than directly recording visual images. Military and security organizations are also investing heavily in advanced wireless sensing systems. Similar technologies may eventually support battlefield awareness, drone coordination, perimeter monitoring, and urban intelligence gathering. As often happens with emerging technologies, civilian and military development increasingly overlap. Autonomous systems may intensify these trends further. Self-driving vehicles, delivery robots, connected factories, and AI-managed infrastructure all require extremely fast environmental awareness and communication. 6G networks are partly being designed to support this machine-driven ecosystem, where infrastructure continuously exchanges information with automated systems. The economic value of behavioral data also drives development. Human movement patterns reveal valuable information about consumer behavior, traffic flow, commercial activity, and social interaction. Data generated by smart city infrastructure may become commercially important for advertisers, real estate firms, logistics companies, and technology platforms. Some researchers warn this could create a form of ambient surveillance where monitoring becomes deeply embedded into normal urban life. Instead of isolated surveillance systems, entire environments become responsive data ecosystems. Streets, buildings, transportation systems, and wireless infrastructure continuously generate behavioral information about populations moving through them. There are also technical limitations that are often overlooked in public discussion. Higher frequency wireless systems can struggle with signal blockage, weather interference, limited range, and infrastructure cost. Building fully functional 6G smart cities would require enormous investment and highly dense network deployment. Many of the most advanced sensing capabilities currently remain experimental rather than widely operational. Nevertheless, the direction of development is clear. Cities are becoming increasingly digitized, interconnected, and dependent on AI-managed infrastructure. The boundary between communication systems and sensing systems is gradually disappearing. Networks designed to transmit information are increasingly being designed to interpret physical environments simultaneously. The broader issue is that surveillance is evolving from visible observation into invisible environmental analysis. Earlier systems watched people directly through cameras and sensors. Emerging systems may analyze physical presence indirectly through the interaction between bodies and connected infrastructure. Human movement itself becomes part of the signal environment. This changes the meaning of privacy inside modern cities. In the past, privacy was often linked to physical isolation or absence from visible observation. In highly connected environments, even ordinary movement may generate analyzable patterns through devices and infrastructure operating continuously in the background. 6G technology is still developing, but the larger transformation is already underway. Artificial intelligence, wireless sensing, smart infrastructure, and predictive analytics are merging into unified urban systems capable of monitoring physical environments at enormous scale. The future smart city may not rely solely on cameras watching citizens. The city itself may become the sensor. If you enjoyed this deep dive into the forces shaping our future, be sure to explore our other documentaries examining the technologies redefining modern civilization. And if you want to keep exploring the biggest questions about science, power, and the future of humanity, make sure to subscribe to the channel and join us for the next journey into the unknown.